This is a generic ESP32 development board. This is the original Arduino Nano. And this is the Arduino Nano ESP32. It's the fusion of these two boards. Is it an Arduino? Is it an ESP32? That's right, it's both. The Arduino Nano ESP32 is the first Arduino board based solely on the ESP32 microcontroller. Other Arduino boards, for example, the Uno R4 Wi-Fi, also uses an ESP32, but it's only used as a coprocessor. On this board, the ESP32 is the whole show. Now, if you're not familiar with the ESP32, it is a widely popular Wi-Fi and Bluetooth low-energy enabled microcontroller. The version this board uses is called the S3. It's a dual-core Extensa LX7 running at 240 megahertz. That's 15 times the clock speed of the original Arduino Nano. Plus, this board packs 500 times the storage, 16 megabytes of flash. The Arduino Nano ESP32 also works out of the box with Arduino Cloud, and it supports ESP Now, a protocol that lets ESP32 boards talk directly to each other wirelessly with no router in the middle. Think like remote controls, wireless buttons, little sensor networks. Now this might be Arduino's only dedicated ESP32 development board, but there are tons of ESP32 dev boards out there. Adafruit makes one, SparkFun makes one, Seed Studio, Programming Electronics Academy makes one. Well, it's in the works. So you might be thinking, what's the advantage of the Arduino Nano ESP32 over all the other options? When you buy an official Arduino board, you can bank on getting solid documentation. They've got support in the forums and a huge number of people using the same board, so you can usually troubleshoot your way out of a problem. Unlike some generic boards where the silk screen might not even match the actual pin number. But beyond that, the big thing you're getting is the form factor. You probably already know this. Arduino organizes their boards in form factor families. You've got the Nano family, the Maker family, the Uno family, the Mega family. Each family has a ton of variants, but within a family, they all share the exact same pinout. So theoretically, you could move a project from one board to another without having to adjust your code at all. Now, there's quite a bit of theory in that, which we'll talk about in a minute, but it's also a nice and compact size. It fits great on a breadboard with room on both sides for connecting components. When you're looking at an Arduino Nano ESP32, one thing that stands out is this shiny metal box with a sticker on it. Mine's got a QR code on top, and if you look really close, it says U-Blocks. This is the ESP32 module. The actual ESP32 chip, the silicon itself, is inside this metal can, along with some supporting circuitry, and this whole thing is part of the antenna. But if you put it next to the Uno R4 Wi-Fi, both boards have an ESP32, but this one looks way bigger. So what's going on? Well, they're both ESP32s, but they've been packaged differently. U-Blocks is a company that takes the ESP32 and builds their own module around it. Arduino chose this U-Blocks module for the Arduino Nano ESP32. On the R4 Wi-Fi, Arduino went with the module made by Espressif. And that's the company that makes the ESP32 chip itself. So different companies make these modules. They have different packaging, but it's the same silicon on the inside. And you can actually go one step further. This SparkFun board doesn't use a module at all. This just has the raw ESP32 chip right on the board, and the antenna is built into the board itself. So why do these modules even exist? Why not just smack the ESP32 board on the PCB and call it good? Well, the company that makes the modules, they handle all the fussy radio stuff. The antenna design, the wireless certification, so that the board maker doesn't have to. So it's a little bit like the easy button maybe. The first thing you'll want to do when you get your Arduino Nano ESP32 is connect it to your computer. It's got a USB-C. This is actually the first Arduino board with a USB-C connector. Once the board's connected, open up the Arduino IDE. I'm using Arduino IDE 2 here, and to use this board, you need to install what's called a board package. So you just go to the boards manager and search for Arduino Nano ESP32. But two packages show up, and maybe you're scratching your head like, which one am I supposed to pick? To answer that, it helps to know what a board package actually is. In Arduino speak, it's called a core. And a core is a translation layer between your code and the actual chip. So when I write code that toggles pin D6 on an Arduino Nano ESP, that same code also toggles pin D6 on my Nano ESP32, even though these are completely different processors. That doesn't happen by magic. That's where the core comes in. It maps the pins that you can use in your code to the real hardware underneath. It also brings in the tool chain that compiles and flashes your code for that specific chip, and it tells the IDE which boards it supports. So these two packages, the one just called ESP32 is made by Espressif. That's the company that makes the ESP32 chip, and it covers a huge range of ESP32 boards. The core that's labeled Arduino ESP32 boards is a package made by Arduino. It's actually built on top of Espressif's core with Arduino's addition for this specific board, like a pin numbering menu, which I'll mention in a moment here. But to answer the question, which one do I install? Honestly, there's no harm in installing both. Arduino's is the official default. It matches all the documentation you see. But some ESP32 libraries track Espressif's newer core, and so there are times when you'll want to be able to select the Arduino Nano ESP32 from the Espressif core, and it ends up fixing a compile error. So just install both, just know which one you've selected. And when I say which one you've selected, I'm talking about when you select your board and port. So once you've installed both of those cores, you go up to this drop down, come down to select other board and port, and then search for the Arduino Nano ESP32. And again, there's two options. The one that says Arduino ESP32 boards, that is Arduino's package. The one that says ESP32 is Espressif's. I would start with picking Arduino's. Then what you want to do is pick your port on the right. Now, if you're not sure which one of these numbers is your port, because sometimes it can be really confusing, what you can do is unplug your board, see which port disappears, plug it back in, and then see which one shows up, and that's going to be your board. Now, as soon as you go to load code onto this board, I almost guarantee you're going to hit one of these three very common gotchas. The first is an error that looks like this: no DFU cable USB device. It's kind of scary looking, and you'll get it about 1 million times. And there's two quick fixes. The first one might work, the second one almost always works. First, just double check that you actually selected the right board and port. It's actually really easy to select the wrong port, especially if you have multiple Arduino boards hooked up. So just double check that. The second thing you'll want to try is to put the board into bootloader mode. And to do that, you just press the reset button twice, and the RGB LED that's on the board starts fading slowly through colors. Once you see that, the board is waiting to get flashed. So try the upload again. When you see this error, I can assure you your board's not broke, you didn't break it. We actually have a video on this specific error because it's so common. It's actually part of a companion guide that I made for this Arduino Nano ESP32, which you can get at this QR code or at the link in the description. It's got everything pertinent on a single page: the documentation, the pinout, the user manual, getting started, data sheets for the board, plus links that help explain some of the quirks on this board that will have you scratching your head. And they're all on a single page. All these QR codes are clickable or scannable. You can download this for free right now. You can get it at the QR code or the link in the description. The other gotcha you are going to run into when using this board has to do with confusion on the pin numbering. Remember when we were talking about the board cores, that translation layer? Sometimes this can get a little confusing because there are two sets of numbers on this board: the GPIO numbers that Espressif's core uses, and the Arduino Nano pin numbers that match the Nano family, the ones that you see on the silk screen. Some libraries talk GPIO, not Nano. So the best way to show you is to bend your brain a little bit with this short sketch. This is a program that uses the ESP32 servo library, and it blinks an LED and it just moves a servo back and forth. But look what I've done here. I've got a variable servo pin set to number 17. And then I have another variable LED pin also set to 17. So what the heck is going on here? Well, here's how this works. The servo library treats 17 as the GPIO number from the pinout. But pin mode and digital write down here, they run 17 through that translation layer, and it maps to the Arduino pin number, which happens to be analog pin A0. So same number, two different pins, one sketch. And to add just a little bit of confusion on top, if you go under Tools Pin Numbering, you can pick by Arduino pin or by GPIO number. And this is a rabbit hole that I'm not going to go down here, but the companion guide I mentioned before, it's got 2 articles that deep dive into exactly how this works. And once you kind of understand what's going on underneath, it makes a whole lot more sense and it's much easier to write your code. A final quirky thing about using this board is how you turn on the RGB LED. If you look at the pinout diagram, it will tell you the Arduino pin is D14 for the red channel, D15 for the green, and D16 for the blue. But if you look at the actual pin documentation where it maps the Arduino pin and the GPIO pin number, you'll see that there is no constant for D14, D15, or D16. You're instead supposed to use LED red, LED green, LED blue. So if you wrote some code that used the D in front of the pin number, you'd actually get an error. And instead you can use just the number itself, like 14, 15, and 16 to refer to the Arduino pin, or you just use this constant. But where it gets interesting is notice here, I've got the red channel set low. And that's because the RGB pins are active low. When you set them low, that's when you're actually going to turn that LED on. Here's the best way to destroy your Arduino Nano ESP32. All you have to do is use 5-volt parts with it. This board is not 5-volt tolerant. It operates at 3.3 volts. Here's what that means practically. Say you've got an Arduino kit that has the really common HC-SR04 ultrasonic ranging module. It's a super common part. Well, it needs a 5-volt supply. So you could power it from the V bus pin that's on this Arduino Nano ESP32. That's 5 volts straight from the USB cable. But the moment that you wire up its echo pin to one of these digital pins, you're going to be in trouble because this sensor talks back at 5 volts. And these pins are only 3.3 volt tolerant. So you could definitely damage the pin and possibly really mess up the board. Now, running at 3.3 volts isn't unusual. Actually, it's way more common than running at 5 volts anymore. And lots of Arduino boards run at 3.3 volts. But you just have to think about that when you're getting your parts. Make sure that they operate at 3.3 volts. And if you're going to power this board through the VIN pin, you're going to want to supply between 6 and 21 volts. One heads up though, that V bus pin only carries 5 volts when you're plugged in to USB. If you power this board through VIN, then that V bus pin is dead. Now there is so much more to say about this tiny board, and the companion guide is a great place to start. Just grab it at this QR code in the description. All those really handy links will be at your fingertips, and you can learn a ton more about this board. Once you've downloaded that guide, the next video you'll want to watch is this one right here. If you're interested in nano boards, this talks about Arduino Nano boards in general. This video right here, it'll probably fill some of these nano gaps in. This one.